We need to test the convergence of the series 1 plus 1 by 2 square plus 2 square by 3 cube up to so on. So if we omit this first term, then it does not affect the series, right? Because the series is infinite series. Or you can also write this first term as 1 the power 0 divided by 1 the power 1. So that it looks similar to the other terms of the series, right? It is your infinite series, you can also omit the first term. So what could be the nth term? It is n the power n divided by, here in the denominator the number is increased by 1. So writing here n plus 1 the power n plus 1. This is your nth term. So if we take this to be our un and then we choose our vn, then we can easily apply the comparison test on this. In the comparison test, we check the ratio of these two. The limit of the ratio of these two, if this limit is finite and non-zero, un and vn shows the same behavior. They shows the same behavior, right? So you can check either of these series to test the convergence. So let's start with the solution. Now this is your given series. If this given series is denoted by summation un, or we can write this as summation un to be equal to the summation, it is the summation of n the power n divided by n plus 1 the power n plus 1. Very fine. So this implies what is un? It is n the power n divided by n plus 1 the power n plus 1. We have to choose our vn, n the power n the same numerator divided by, from this only we have to choose vn, we have to guess vn, n the power n divided by n the power n plus 1, right? So this is equal to n the power n divided by n the power n into n. So cancelling this, we are getting vn to be equal to 1 by n. This is un and this is vn. Try to make vn to be as 1 by n only, right? From this un. And now checking the limit on un divided by vn. Let's check this limit is coming out to be finite or not. Limit un is n power n divided by n plus 1 the power n plus 1, and then writing vn to be as 1 divided by n. Because the series is infinite series, so limit is n tends to infinity. The limit is on un by vn, n tends to infinity. So this is equal to limit n tends to infinity. In the numerator we get this to be n the power n plus 1 divided by n plus 1 the power n plus 1. So this is equal to the limit n tends to infinity, n the power n plus 1. I can write the denominator as n the power n plus 1 if I take n common. So it is 1 plus 1 divided by n the power n plus 1. So these two cancelled out. Further we can write it as 1 divided by 1 plus 1 by n the power n into 1 plus 1 by n. And then applying the limit n tending to infinity over here. In the second bracket, this comes out to be 0. 1 by n tends to 0, so it is 1. When applying the limit over here, we get this to be 1 divided by 1 plus 0. So that is equal to 1. And this is your formula. If the limit is on 1 plus 1 by n the power n, if this denominator is same with the power, then this limit is equal to, I'm writing here, limit n tends to infinity on 1 plus 1 divided by n. If the denominator is same as the power, then this limit is equal to e. So this will be 1 divided by e, and this limit is non-zero and finite. So by comparison test, summation un and summation vn shows the same behavior. And we need to check the convergence on the summation un, because we have taken the series to be the summation un. We need to check the behavior of this series. So by comparison test, these two series shows the same behavior. Let's check the behavior of the series summation Vn. What is summation Vn? It is the summation on 1 divided by n. Because this is your auxiliary series, what is auxiliary series? If the summation 1 divided by n the power p, auxiliary series is the kind of series the summation is on 1 divided by n the power p. This is the format for the series, the auxiliary series. This series converges if p is strictly greater than 1, and the series diverges if p is less than equal to 1. This test is also named as p-test. So by p-test we can check this series now. Here what is p? It is equal to 1. So it is your divergent series. Because for the condition of divergence, p should be less than equal to 1. Either strictly less than 1 or is equal to 1. So here because p is equal to 1, so this series is your divergent series. So writing this, by p-test, summation Vn is divergent series. Because now we know the behavior of this series, that it is a divergent series, and the comparison test says that these two series shows the same behavior. We have checked this series to be the divergent series, which means this series is also your divergent series by comparison test. So therefore, by comparison test, summation un is divergent series. And what is summation un? It is 1 plus 1 divided by 2 square plus 2 square divided by 3 cube. That is your given series. So your given series is divergent series. It is not convergent. Alright, thank you.